Okay, a sample question of working with surds, a common question or common reason, a common thing to do is to simplify a surd. Surds simplify kind of like fractions. Okay, if you have a surd answer, you should express it in its simplest possible form. So looking at these questions over here, probably you've never seen something like this before, but we're going to attempt to simplify these and express them in simplest possible form. In fact, if you type this in your calculator, it'll actually do it for you, but you need to be able to know what's going on. Okay, so let's have a look at the first one. Okay, and we've got the square root of 32. Okay, so you can't square root 32, but what you can do is you can split 32 up into factors. Okay, so 32 has quite a few different factor pairs, and what we're looking for is square factors. Okay, because we're going to square root the factors. Okay, so let me just explain. You try to find the biggest square factor that the number has. So if you think about 32, we've got 32 and 1. Okay, there's no square factors there. 16 and 2, 8 and 4. Let's try 16 and 2. Okay, so 16 times 2 is 32. We can say that this is true. Okay, so square root of 32 is equal to the square root of 16 times 2. Okay, now there's a law in surds which says you can say the square root of 16 is the same, square root of that 16 times 2 is the same as square root of 16 times the square root of 2. Okay, so I've just split those two up into separate radical signs. Okay, now if you have a look at these two surds now, we've got two separate surds. The first one, the square root of 16 is actually 4. Okay, so we can simplify this to 4. Okay, the square root of 2 does not simplify, so that stays the same. So we say that's just root 2. Okay, now 4 times root 2 we say is just 4 root 2. Okay, so in its simplest form, the square root of 32 is 4 times root 2 or 4 root 2. Okay, in fact, if you type this into your calculator, either the scientific one or the CAS one, it will actually spit out this answer. Okay, which is can be a little bit confusing if you're doing Pythagoras or something like that. Might have come up last year. Why does the calculator do this? Okay, it's just simplifying it for you. Okay, now second one there. Let's do that. 3 square root of 200. Okay, so we've got, it's actually 3 times the square root of 200. It's like an algebra pronumeral. This means there's a times in there that we don't show. Okay, 3 times the square root of 200. All right, so what we're looking for, square root of 200 does not simplify nicely, but we can split it up into factors. Okay, so we can write this as 3 times the square root of 100 times 2. Okay, now that is equal to 3 times, okay, I've just put the times in there, square root of 100 times square root of 2. Okay, I'm just splitting them up into separate surds. Okay, hopefully you can see that 100 is a square number. So that would be 3 times square root of 100 is 10 times the square root of 2. Okay, we simplify it again, we get 30 root 2. Okay, so that's 3 root 200 in simplified form. Okay, you cannot simplify that any further. Root 2 does not simplify. Okay, C, we've got 5 root 40 over 6. Okay, root 40 is what we're going to be working on. 40 has some square factors. I can write that as 4 times 10, okay, over 6. All right, that's the biggest square factor that I can find out of 40, I think. Yep. So again, I'm showing all these steps at the moment because we're just starting. So I am putting all these in. Okay, so the square root of 4 will be 5 times 2 times root 10. over 6. Okay, so 5 times 2 is 10, root 10 over 6. Okay, 5 times 2 is 10, and I've just left a 6 there. You can actually simplify this further by cancelling out 2 from top and bottom. Okay, so that will be 5, and that will be 3. Okay, so that will give you 5 root 10 on 3. I encourage you to have a go at typing one of these in your calculator. So have a go at putting that in your calculator and seeing what happens. Okay, it should give you this if I've done it right. Okay, finally we'll do D. I can just see that, so let's write that down here. So the square root of 75 over 9. Okay, so let's simplify that. See if I can just put that down a bit. There we go, I'll put it over here. Alright, now there's a reason why surds and indices are put together. They're actually related. They're actually different forms of the same thing, but there's a particular rule, index rule, which says that if you have the square root of a fraction, a fraction to the power, all to the power, you can do the power to the top and the bottom, and it applies for the square root sign as well. So you can say this is the same as 75 over square root of 9. Okay, so the square root applies to top and bottom. Alright, so hopefully you can see down the bottom, square root of 9 is just 3. Now the square root of 75, this is where your times tables come in handy, because I don't think 75 is on any times table, but 75 has a factor of 25. It can be written as 25 times 3. Okay, square root of 25 is useful because that is 5. Okay, so hopefully you can see that this will be 5 root 3 on 3. Okay, I cannot simplify that any further. Root 3 doesn't square simplify, and neither do the coefficients out here. Okay, that's how you simplify surds.